Hello everyone, welcome to the 7th video on the Snowpro core certification series. In this video, we are going to discuss about file formats, sequences, streams and tasks within Snowflake. Without further ado, let us see in detail about each and every section. First, let us talk about the file formats. File formats are the named objects that can be used for loading and unloading the data into the Snowflake. There are currently 6 formats which are supported, which are CSV, JSON, Avro, ORC, Parquet, and XML. Formats that are supported for both loading and unloading of data are CSV, JSON, and Parquet. Tactically, all the 6 formats are supported for data loading. Only there are some caveats for the data unloading alone. That is the reason why that is mentioned as for both loading and unloading as CSV, JSON, and Parquet. Avro, ORC, and XML are not supported while unloading the data from Snowflake. Right, moving on, there are multiple ways by which we can create the file formats within Snowflake. One typical way is using the snow site, which is the Snowflake's web UI, and also using the SQL as well. We can create the file format. There are lots of options which are available while creating the file formats, like compression, skip header, skip blank lines, trimming the spaces, fields optionally enclosed by field, error on column count mismatch, etc. And to understand more about this is the Snowflake documentation page, which provides the complete set of parameters which are part of the create file format SQL command. Here we can see all the statements which we discussed earlier are mentioned here. So please glimpse through this. I will attach the link for this documentation on the description on the video as well. And then the schema defined in the file format must match the schema of the Snowflake table. This is very evident while creating the external table statement. If the schema of the Snowflake table doesn't match with the schema of the file format, then the external table create statement will fail. Partitioning loading, meaning we want to load some subset of data from the bigger chunk of data, that is supported only for 3 file formats, which is ORC, Parquet, and JSON. Here are the set of file format create statements and the stage statements. Please have a look into it. So this is the file format create. Here we are creating my CSV format as the type of the CSV, which is delimited by pipe. Pipe is the delimiter, and then we are going to skip the first header of that file. Now using this file format, we are creating this stage. My CSV stage is created using my CSV format, and similarly we can utilize the storage integration as well while creating the stage, but the file format remains the same. Then using that stage, we will be loading the data into the table using the copy into command. So these file formats are very important while staging the data into the stages. Here is the example for the similar JSON. So more or less same as we saw for the CSV. Here we are defining it as JSON, and then using the same file format we are loading it into the my JSON stage, and then we are loading the my JSON table using the my JSON stage. Now we are going to discuss about the sequences within Snowflake. Sequences is an interesting feature which is predominantly available in most of the database systems to generate an uniquely identifiable value, which is an continuously running value as well. So sequences are used to generate unique numbers across sessions and statements, including concurrent statements. Used to generate the values for the primary key. If you remember, typically on the data warehousing world, primary key is the one which uniquely identify the column or a row on the table. Typically the employee ID can be the primary key for the employee table, meaning the employee ID will be unique for each and every record. In those use cases, we can very well utilize the sequences. Snowflake does not guarantee generating sequence numbers without gaps. The generated numbers are not necessarily contiguous. We are going going to see a detailed example for this. Now coming to the SQL statements, create or replace sequence, it will start with 1 and it will increment with 1. So we are creating a sequence table as well, just for loading purpose and see how it goes. So now we are executing select sequence 1 dot next val, it will give me the first value which is 1. Now if I can execute the same statement again, it will give the next value of 2, it is getting incremented by 1. Now I am going to insert some of the value, the whatever the value there in sequence 01, the next value into this table. Now try to guess what is the value which is going to be available in the sequence table, the sequence test table. Yes, it is of course 3. Why? Because at the time it was 2, then we used the next val, it is the 3. So the value of 3 got inserted into the sequence test table. Here we are trying to do something different. Instead of incrementing it as 1, we are going to increment it with 5. So you can fire a statement like this: sequence of next val, of next val, of next val, or next val. So 4 times we are running it. So each and every time it is getting incremented with the multiples of 5. It will start with 1 and then 5 got added, it will be 6, and then another 5 got added, it will be 11, then another 5 got added, it will be 16. Now if I fire a same statement again, our expectation is mostly 21. Why? Because 16 plus 5 will be 21. Instead of 21, it started with 36. That is the reason why there is a clear mention. There is no guarantee for generating the sequence numbers without gaps. The generated numbers are not necessarily contiguous. Now we are going to discuss about tasks within Snowflake. In simple ways to represent tasks are the mechanism within the Snowflake which will be helpful to schedule something meaning if you want to schedule a job, if you want to run a SQL statement at a specific interval of time, all sorts of scheduling can be achieved using tasks within Snowflake. So you can execute single SQL statement, you can call a store procedure within the task, you can write an procedural logic using Snowflake scripting using SQL. So any means of any code can be done using task. Task can be combined with streams for continuous ELT workflows to process recently changed table rows. This is all about the change data capture, all part of the Snowflake streams which we are going to discuss in the same video. There are two different tasks which are currently available. One is the serverless task where Snowflake manages the compute part of it. So for the task to run, we need a compute to be added to it. So that compute is completely managed by Snowflake when it comes to the serverless task. The other form of task is the user managed task where we need to specify the compute by providing the existing virtual warehouse as the part while creating the task. Now we can see this in more detail using the SQL statements. Here is the example for the serverless task. So the task T1, which is supposed to run every 60 minutes, is going to insert into the table of my table with the values of current timestamp. So at every 60 minutes, whatever the current timestamp will be inserted into this table. Now the user task manager initial warehouse size is X small. This is very important. Using this statement only we can identify whether it is a serverless task or a user manager task. So it will start with X small as the ideation or initiation phase, and Snowflake will automatically increment the size of the warehouse based on the workload for the task. Here is the example for the user managed task. Here we are specifying the warehouse as my WH very clearly at the time of the task definition. So my task, however, it is going to run as a user managed task with the warehouse of my WH, and the schedule it is using the cron. We can very well utilize the cron to do the schedule. Cron is the well-known mechanism for scheduling which is prevalent for a longer duration of time. It is very very evident on the Unix and Linux based systems. We used to schedule lot of jobs using the cron tab. Similarly, we can schedule the Snowflake jobs as well using the cron expression. Here it is just doing the select current timestamp. So the bottom statement is more or less same as the one which we did on the serverless task. It is going to run for every 5 minutes using the my warehouse, and it will take the current timestamp at that time and it will insert it into the my table. For the task, there are set of workflow which we need to follow. Workflow meaning how we can create a task. For a task to be created, there are three set of steps which needs to be followed. First is the creation of the task admin role, where we will be creating a task admin role which will grant the specific user or a specific role to create a task. Then what we will do, we will be creating the task using the create task statement. By default, the task which is created is suspended. So the initial suspension is an important point to remember. Here we are creating my task minute, which is using the my wh, which is an user managed task which is going to run for every 5 minutes. As usual, it is going to insert the current timestamp at that time into the table of my table. Then we need to fire the resume command, because this task is created in the suspended mode while creating. Then we need to use alter task followed by the task name and then the resume command to resume this specific task. Moving on, we are going to discuss some important feature and interesting feature of task which is called as the task graphs. We can combine the tasks together, meaning I can create one task which is dependent on another task which is dependent on another task. By doing so, we are creating a chain relationship between the task. That can be done using a task graph which is called as the DAG, which is the direct acyclic graph. If you are from the data engineering background, you are very well aware of the DAGs, which is part of the Airflow, where in which we are doing the same set of procedures. So it is a series of tasks that is composed of a single root task and additional task organized by their dependencies. Flow will go in a single direction, meaning a task later in the series cannot prompt the run of an earlier task. That is a very important thing to know. So the flow will be going in an one directional way alone, and then each task except the root task can have multiple predecessor tasks, right? This we are going to see in more detail. Each task can have multiple subsequent tasks, meaning the child tasks that are dependent to it. A task runs only after all the predecessor tasks run successfully to completion. This is very important. So the child task cannot run unless the parent task got completed. The root task should have a defined schedule that initiates the run of the task graph. So for any of the root task, we need to define the schedule. You can specify the predecessor task while creating a new task. Usual, right? We created a task using the create task statement by specifying the after command, or else what we can do, if you want to add the dependency later point in time, we can very well use the alter task command and you add the after statement to it. A task graph is limited to maximum of 1000 tasks in total, including the root task. A single task can have maximum of 100 predecessor tasks and 100 child tasks. These are all something which is very, very important from the exam point of view. Now you can see this diagram. This is very well took from the Snowflake documentation. A is the root task. B and C are the child task which is dependent on A, meaning only when task A got completed, then only task B and C will be initiated. D is dependent on both B and C, meaning until both B and C tasks got completed, then only the task D will get initiated. For more meaning understanding, you can see here this is the root task and these are all the child tasks: updating a customer table, updating a product table, updating date and time table. Once all these three tasks got completed, then only the aggregate sales table task will get initiated. Now we can see the command which is used: create task 5, after task 2, task 3, task 4, then we are going to insert into the table using the current timestamp. This can be very well represented in this diagram. If you see, task 5 is completely dependent on task 2, task 3 and task 4. Now we are going to discuss something called as streams within Snowflake. The streams is all about change data capture. What is a change data capture? I am having a table. On that table, I am going to do some operations, some insert, some delete, some update. Based on those operations, I want to do some other operations on some other table. Those sorts of things are called as the change data capture. That is very well added in Snowflake in the form of the streams. So what streams is all about? Streams tracks for the changes made to the tables, views external tables and directory tables within the Snowflake data platform. They capture inserts, updates and deletes using the DML statements. Ideal example is the change data capture in the data pipeline. This diagram again I took from the Snowflake documentation will very well explain how the streams work. If you see the source table, there is a version 0, version 1, version 2, version 3, and after version 3 we started our stream 1. Then what it does, after that there is version 4, version 5, version 6 till version 10, meaning there are various changes which happened over the table. And now what it does, this CDC stream contains all the changes from the version 4 till the version 10. The streams comes with three main important fields actually: metadata action, metadata is update, metadata row id. We are going to discuss more in detail about it. First let us understand what these things are. Metadata action indicates the DML operation. Typically insert or delete type of an operation happened over the table, that will be recorded in metadata action. Metadata is update is a true or false field which is set to true for any of the update statement. Typically in the streams the update will be taken care by two-step procedure. Update rows to the main source object are represented as a pair of delete and insert records. So how it is represented? It is represented in two records in delete and insert. Both the records will be having a metadata is update value set to true. Last one is the row id. There is no much of a significance for this. This is the uniquely identifiable id which is immutable, which is used to track the changes over the period of time. So coming to the other part, which is the types of streams. There are three types of streams. Standard streams tracks all the DML changes to the source object, including inserts, updates and deletes. There is the append only stream. Exclusively it will track row inserts alone. Update, delete and truncate operations are not covered. Insert only streams are also there, which tracks the inserts only, do not record the delete operations that remove rows from the inserted set. To understand more, there is a fantastic diagram which is available in the Snowflake documentation. I successfully stealed this diagram from the Snowflake documentation as well. Now we can see there is a table with, this is the version 1 of the table, which contains the only one record, which is the apple as the column 1 and column 2 as 5. So streams got enabled on the table. Now the insert happened over here for this apple record. It is mentioned in the metadata action as the insert, right? And then the metadata is update is false and row id is the unique number. Now what we are going to do, we are going to insert two new records, which is orange and banana, and we are going to update the apple record with a new field of 9. Now the 5 is updated with 9. Now you can see how it is getting changed in the streams. Orange is an insert, banana is an insert. The update record of apple 9, as we discussed earlier, there are two records which got inserted with the metadata is update field as true, which is a delete and then the insert. You can see apple 5 got deleted and apple 9 got inserted. And finally we are issuing a delete command to it. Typically you can see the blacks are insert, red is the delete and blue is the update. update. Now we are firing a delete for the banana record. That is again the metadata action holds the delete as the function, and then the metadata is update flag is false. So these two things, metadata action and metadata is update, is very important. You can now, I think you can clearly understand how these two fields spans across for any of the inserts, any of the deletes, and any of the updates. Now the important feature which we talk as the part of the tasks, actually, where we discuss this can be combined with the streams. Now this is the place how we are combining the task along with the stream. You can see this here, create my task. It is using the user defined task using the my wh as the warehouse. It is going to run for every 5 minutes, and you can see system stream has data my stream. So whenever a data got inserted into the stream of my stream, then only this task will be created or initiated, and it will insert the data into the my table based on whatever which is there. See, now it is inserting only the insert record from that my stream into the table of my table 1. Now we successfully combined both the task and streams together. Without concluding the video, I just wanted to go through the set of documentations from Snowflake, which is very helpful for the exam point of view, which we already saw the file formats. And with respect to the sequences, here is the set of documentation which will help you to understand how I can create the sequence, what are all the various parameters which I can add as the part of the creation of the sequence, everything. And this is all about the tasks, whatever which we saw, serverless task, user manager task, how you can choose the warehouse sizes, all these things, recommendations for choosing the compute model, when you can choose serverless task and when you can use my user managed task, and the task scheduling, how we can schedule the task graph. All these things are clearly mentioned here. Please glimpse through this. And similarly for the streams portion as well, here you can see the table versioning, how we can do the repeated read isolation, all this metadata is action, update and row id, what are all the types of the streams, how the data flow looks like, how we can do the data retention period and stainless. Everything is mentioned here as the part of this documentation. With this, we came to end of this video. I hope this video has been informative for you. Please do write lot of comments that will help me to enhance the contents for these videos. Thank you very much for watching this video.